Okay, we'll look at this list problem. We're even keel, upright. We're given our draft, breadth, kg, and told further particulars of the vessel can be found in the booklet. A heavy lift derrick is to be used to discharge a 60-ton tank from a centre line position. We're given the height of the derrick head and the distance from the centre line when moving our crane over the side. And the first thing asked us for is the maximum list angle. So we've got to appreciate when that will occur. So here's a sketch, and what we're saying is that the weight has been taken from the centre line and it's been swung over, ready to discharge. Hopefully you'll see that the maximum angle of list has to be just before we discharge it, when it's distance of 15.8 from the centre line. And I've put there that the height from the keel to the mast to the top of the derrick is 29.28. So again, it's important to know with that the kg of the weight, once you've picked it up, is 29.28. So let's look at the maths involved in the first part. Go in the tables to get with your displacement to get your draft. We can get our km now because of course our displacement isn't going to change in this part. So what we're going to do, we're going to take the 60 tons from 5.23 with no distance off the centre line for listing moments because the weight is on the centre line, and we pick the weight up at that kg and it's going to be swung over that distance. So we can find our final kg, km, which doesn't change of course, gm 0.38, listing moments 60 times 15.8 gives us 948. There's the formula. So the maximum angle of heel, 10 degrees. The second part asks us to calculate the increase in draft when the vessel is at the maximum list as calculated. On your formula sheet you will see this particular formula, and the angle theta will be the 10 degrees. So we're given our upright draft, half the beam, so we're given our breadth there. If we weren't given that, we would go in the tables to get it, use half that, and we find that our draft when heeled is 8.47. We were asked for the increase in draft, so subtract one from the other, our new draft from our initial draft, and we see our increase is 1.67 meters. So don't just stop at 8.47. They've actually asked for the increase in draft, which we've just worked out there. Part C says, okay, we need to limit the list angle to 5 degrees. So what should our kg be prior to discharging? Okay, and really you should get our angle at the moment in 10 degrees. We want to restrict it to 5. So when you get your final kg, it has to be less than the initial kg of the vessel, because that will give us the lesser angle. So what we have to do is put this formula down. We know the angle of list has got to be 5 degrees. We know the listing moments, they can't change. The displacement can't change, but what will change in the formula is the GM. So by transposing the formula, our GM at that point has to be 0.77. And you'll notice that it's different from when we calculated the GM before, 0.77. The KM 8.36, that's not going to change. So the kg at the lift has to be 7.59. So what we do is now reverse the process because we want the initial kg. So there's our displacement. There's what the kg has to be at the point of list of 5, maximum list, which is going to be 5 degrees. Then we're going to take the weight off the derrick and we're going to place the weight back in the hold. So we're going to minus this value and plus this value, and that then gives us the kg maximum allowed to keep the list to 5 degrees, and it's 7.49. And you'll notice initially it was 7.88, so we know we're pretty correct there. 7.49 will be the initial allowable kg to keep the angle of list at 5 degrees.